Hello, Algebra and Algebra 2 students. Today we're going to take a look at box and whisker plots. So you want to have your box and whisker plots 11.2 notes packet out so you can take notes along with the video. So if you're not familiar with box and whisker plot, there's some vocabulary we need to go over first. So we're going to fill that in. So a box and whisker plot is a data display that organizes data values into 4 groups. Then the other vocabulary kind of applies to those groupings. The lower quartiles are like quarters because we're dividing the data into 4 groups. The lower quartile is the median of the lower half of an ordered data set. So the word ordered there is important, as we don't divide the data into 4 parts until they're put into rank order. So you do need to make sure you're putting things in rank order before you're finding these values. The upper quartile then is the median of the upper half of the ordered data set. The lower extreme of a data set is the least data value. So it's the lowest data value in the set. And the upper extreme is the greatest data value. The interquartile range, abbreviated usually as IQR, is the difference of the upper quartile and the lower quartile. The upper quartile is sometimes known as Q3. So IQR, difference of the upper quartile and the lower quartile. Lower quartile, sometimes known as Q1. All right, so let's take a look at making a box and whisker. So we have a supermarket manager recording the number of store visits for the last 7 days, and the data are given below, and they give you a list of data. And we need to, as I mentioned before, put that data in order from least to greatest, because it needs to be ordered data before we do a box and whisker plot. So we're going to put that data into order from least to greatest. So I would start with 90, and my next value is 120, 124, 130, 160, 165, and 220. So to create a box and whisker, you put the data in order first, least to greatest. The next step would be to find the median. The median is sometimes referred to as Q2, and that's dividing the data in half. Then you need to divide the data in half again to find that lower quartile. And so when we have 3 pieces of data in the lower half here, so that Q1, or the lower quartile, would be 120 because that's the middle of the lower half. And the Q3, or the upper quartile, is the middle of the upper half. And so that's 165. Notice the note on the left is that when the data has an odd number of values, you don't include the median in either half when you're determining the upper and lower quartiles. Now, if we would have an even number, we would have to calculate the medians of both, like the Q2, Q1, Q3, of all of those. So if you have 2 values that are falling in the middle, you just find the average of those values to find the Q values. Then we want to plot those values that we found on a number line. For a box and whisker plot, you don't plot all of the values on the number line. You just plot the critical values, which are the extremes and the Q values. So we plot the extremes. So our lowest value is 90. So I'm going to plot that. I'll just put a dot. Usually a box and whisker plot is not on a number line. It's either kind of floating above or below. We're going to make ours below. And so that's 90. And again, usually because it's kind of floating near that number line, we usually label the values, sometimes labeled with the number, sometimes labeled with abbreviations. So I'm going to show you both. So 90, or LE for a lower extreme. Then we plot our upper extreme, and our upper extreme, or the highest value, is 220. Again, just putting that dot on, and I can label the value, and I would do UE for upper extreme. Then I plot my Q values, and my lower quartile is 120. And on that, typically labeling with Q1. And my upper quartile is 165. And that's the upper quartile, or again, Q3. And my median was at 130. So what you're going to see is that the data is divided into quarters. We divided it into half and half again. But the use of the box and whisker plot is that you can see how those quarters are spread out on the number line. And we draw a box around the Q values, and we stretch our whiskers out to the extremes. So even though that data is divided into quarters, the box and whisker helps you see that spread on the number line, and you can see that even though there's the same amount of data into each part, in each quarter or quartile, each quartile is not evenly spread out over the number line. And that's partly how a box and whisker is useful. So one of the best ways to use a box and whisker plot is to compare box and whiskers. So you can see we have 2 box and whisker plots in the same number line here. That allows us to compare them. So the box and whisker plots shown below show a class's test scores for 2 different tests. And we can make some conclusions about that. So the blank are the same for both tests. You can look at the box and whisker, which Q values, or which values, critical values, are the same for the box and whisker plots. Good, that's the upper extremes. Now, because we didn't create these box and whisker plots, we don't know all of the test scores. We just know the 5 critical values. If we don't know how many test scores there are, we don't know that the test scores, like even the Q values, could be averages of test scores. So the only ones we know for sure are the extremes, because they would be taken right from the list. But we know enough to compare. So the median for the second test is blank than the median for the first test. So looking at the second test, and the median for the first test, so I'll just highlight that in green, or the median for the second test here, is that value in the middle part of the box. And for the first test, the median for the first test is right there at 78. So we can see that the median for the second test is higher than the median for the first. Then we're comparing, okay, the blank for the first test is the same as the blank for the second test. So we've already labeled the upper extremes, so we're going to keep the upper extremes out of there, and let's take a look at some other way to kind of compare two different values. So if we look at the upper quartile for the first test, so the upper quartile for the first test would be 84. So now that's where I should have used my abbreviation Q3. That would have fit better. For the first test, is going to be the same as that part in the second test, which is the median, or Q2. So we want to compare again. So the scores for which test are more spread out than the scores for the other tests. So we want to look at that. So for which tests are they more spread out? And hopefully looking at that, you can see that the scores for the first test are more spread out than the scores for the second. Both the range, 91 minus 62, so the range difference between the highest and the lowest, if you were not familiar with that, and that gives us 29. And the interquartile range, the IQR. The interquartile range is that difference between the Q3 and the Q1. It's basically the range of the box. 84 minus 72 is 10. So of that first test, the range and the interquartile range are greater than the range, again, difference between highest and lowest, and the interquartile range, range of the box, of the second test. So main points there are looking at range being the difference between the highest and the lowest, and interquartile range is basically the range of the box, Q3 minus Q1, and that's another way to compare the box and whisker plots. So let's do a checkpoint. So the parking cost in dollars at several baseball stadiums are given below, and we have a list of those, and our job is to make a box and whisker plot of that data, and then find about what percent the stadiums charge $9 or less. So our first job is to make that box and whisker. In order to make the box and whisker, remember, we need to put the data in order. So down below, I'm going to start putting my data in order. I'd love for you to pause the video and do the rank order list and then check with mine. So I've done a rank order list, and one of the things that's important to do is to make sure you're not missing any values. When you do a box and whisker plot, you're dividing things up. So if you miss a value, it can kind of make all the other values incorrect. So you do want to make sure you double check the count. So we have our rank order list. Then we need to divide the data into 4 quarters. So I like to divide my data in half first. So I've got 9 values. That's going to make the 9 in the center there my Q2 or my median. So I like to just circle that in the list, remembering that if it's a value, then I don't include it in either half. The next step is to find the medians of the upper and lower half, or the Q1 and Q3. Now in this set, the middle of the lower half is going to fall between 6 and 7. So that's going to be 6.5. Now, if it's, nice whole numbers like that, we can do that work in our head and just say, okay, what's halfway between 6 and 7? If they're decimal values or it's not values that you can find the, median right away for, you just calculate the median by adding the 2 values and then dividing by 2. And the upper quartile, or the Q3, would fall between 11 and 12. And that would be 11.5. And then, of course, I have my lower extreme of 6 and my upper extreme of 15. So I like to label them in the list, but you don't need to do that. It's just taking you through the process of making the box and whisker. Then we want to plot those 5 critical values on or below the number line. So again, pause the video, plot your dots, and then check with mine. Once you've plotted your 5 critical values, you create the box by making lines through the Q values and connecting them. And then you stretch your whiskers out to the extremes. Now we want to answer the question, about what percent of the stadiums charge $9 or less? So I'm going to look at my $9 mark. And I notice that there are 2 sections of the box and whisker that are below the $9 mark. Because we divided the data into quarters to create the box and whisker plot, each section is 25%. Because that's what dividing into quarters will do. And I notice that I have 2 sections below the $9 mark. So that means the answer to my question is 50%. If you have any other questions about box and whisker, please take them to your teacher.